In this video, we are going to find the moment and product of inertia of a uniform circular disc or plate of radius a about its center. So first of all, we are considering, you can check here the diagram, we are considering a disc, okay, a circular disc whose radius is a. So we'll try to consider one element here. So we consider one element here on the disc, okay, so such that it makes an angle theta here, and this makes an angle theta. So when you take, I'll take one point on this element, so if I take a point on this element, this point I'm denoting as, since it is in a plane, the any coordinate of a point will be represented in this way. So it is nothing but x, y, 0. So it is in the plane. So this is your x coordinate, will be your x, and z will be lying perpendicular to the plane. Okay, so z will be this axis. So this is your x-axis, this is your y-axis. Okay, this is your y-axis, and z-axis will be perpendicular to the plane of this paper. So the disc is lying on the xy plane. So the disc is lying on the xy plane. So the coordinate of this point is nothing but x comma y comma 0. So from here we'll try to find what would be it is. Okay, so since it is lying in a plane, okay, so it is a two-dimensional object, so here we are going to find mass per unit area. So if I take the mass of this point as small m, then the mass per unit area of this will be nothing but m by pi a square, because the area of this is nothing but a circle, so the area of the circle is pi a square, so the mass per unit area will be nothing but m pi a square. So where m is nothing but the total mass of this disc, okay, where m is nothing but the total mass of the circular disc. Now here we are taking a point P, and we are trying to measure the distance from the x-axis as well as from the y-axis. So the distance of this point from the x-axis is r sine theta, and the distance of the point P from the y-axis is r cos theta. Okay, and the distance of the point P from the z-axis is r. Okay, so it is r. So how we are getting this? Suppose you can see here. Suppose I take this is your xy plane. This is my x-axis, and this is my y-axis. So I'm taking a point here. This coordinate of this point is x comma y comma 0. So this distance, this distance will be nothing but it is x, and this distance is nothing but it is y, and this distance I'm donating to be r. Okay, so this angle made is nothing but taken as r cos theta. So I'm trying to find what will be the perpendicular distance from this point to this. Okay, I'm trying to find what will be the perpendicular distance. So if you try to find this, if you try to find this is the perpendicular, this is the base. Okay, so if you try have this relation, sine theta equal to perpendicular by hypotenuse. Okay, so we can see that the perpendicular distance from this point to the x-axis is y. So we are going to find what will be your y. So sine theta, here we have this sine theta, which is equal to perpendicular is y, so we have y, hypotenuse is nothing but r, so we have taken here r, so we get here y equal to r sine theta. So we got the perpendicular distance from this point is nothing but y r sine theta. Okay, so in the similar manner, if I try to find the perpendicular distance from the x-axis, so this will be nothing but this, and this is a rectangle, so this will be also nothing but x. So we are going to find what will be this. Okay, so this angle also I'm taking as theta, so this become your base and this become your perpendicular. Okay, sorry, this will be not theta, it will be 90 minus theta. This will be nothing but 90 minus theta. So you'll try to find with this. So we have here cos 90, if I take here sine 90 minus theta. Okay, we have this is equal to perpendicular by, so let me try to again. So this I'll take as what, sine 90 minus theta, which is equal to perpendicular by hypotenuse. So perpendicular is here x and the hypotenuse is here r. So here we get nothing but here we get as cos theta, which is equal to x by r. So we have here x is equal to r cos theta. So the perpendicular distance from this point to the y-axis is nothing but r cos theta, and the perpendicular distance from the x-axis is r sin theta. So if the plane, if the we know that the z-axis will be lying perpendicular to the z-axis. Okay, if we do the z-axis, will be lying perpendicular to this plane. So the perpendicular distance from this point to this point is nothing but r. Okay, so that's why we get the perpendicular distance from the point P to the z-axis is r. So here we are taking in that way the distance of the point P from the x-axis is r sin theta, and the distance of the point P from the y-axis is r cos theta, and distance of the point P from the z-axis is r. Okay, so we'll try to find what will be the mass. So first of all, if you can see here also, you can see in this diagram, so this strip I'm breaking in this form. Okay, so if I break in this form, so the angle made, suppose if I take this strip here, I'm breaking into this form, so the small angle here we are donating as d theta, and this is the radius. Okay, so this is r and r, and this thickness of this strip I am taking as dr. Okay, so we have to find what is L. So we know this formula we have learned in class 10 this or class 11, theta equal to L by r. And so here the angle is the small angle is denoted by d theta and equal to L. R is the radius, so we get length is equal to r d theta. So this is r d theta. So here we get here as r d theta. So this is nothing but r d theta. So if you look nicely, this is almost similar to a rectangle. So the area of this rectangle, this is the length and this is the breadth. So length is L and the breadth is dr. So the area of the rectangle is nothing but length into breadth. So we get r d theta into dr. So area of the element is nothing but length into breadth, that is r d theta into dr, which is equal to r d theta dr. So we have here we have r d theta dr. So we get here r d theta dr. Then mass of the element. Okay, so we are trying to find mass of the element. So mass of a single point, that is nothing but m, and mass and area of this element. So area of this mass of a single point P and the area of this element. So mass of this point P is nothing but m, and the area of this element we have already calculated. It is r d theta dr. So we get here m r d theta dr. So we try to find the moment of inertia about the x-axis. So that is equal to summation delta m y square plus z square. So we put the coordinate of the point as we have taken the point as x, y, 0. So we'll try to put the z coordinate here 0. So we get here summation delta m y square. So it is in a plane, so we'll have two integrations. So now the integration is we have here the mass as mr d theta dr, and the distance from the distance from the x-axis is nothing but r sin theta. So we have here r sin theta whole thing square. So we get here nothing but we get, if we multiply everything, we get here mr cube sine square theta d theta dr. Since d theta, so you know that in one round the angle made by a circle in to complete one round is nothing but 0 to 2 pi. So that's why we are changing the angle from 0 to 2 pi, and the radius, so you know the radius of the circle is a, so that it will range from 0 to a. So we have here 0 to a. So we take here this m is a constant, will come out. So we have here 0 to a r cube dr, and we try to integrate this sine squared d theta. So if we look this one, we have m r cube m 0 to a r cube dr, and 0 to 2 pi 1 minus cos theta to 1 minus cos 2 theta means sine square. We'll try to put the value, so we get 1 minus cos 2 theta by 2 d theta. So 2 is a constant, will come out, and we try to integrate this. So if we integrate 1, we get theta, and if we integrate cos, we get sine 2 theta by 2, and we put the limit. So if we put the limit here, we get nothing but 2 pi r cube dr. So we try to integrate r with respect to dr. So we are trying to integrate this, so we get r4 by 4, and we put the limit. So we get here nothing but 1 by 4 ma square. So we are getting the moment of inertia about the x-axis to be 1 by 4 ma square. So similar way, we'll try to find the moment of inertia about the y-axis. So we try to put the coordinate of z to be 0 here. So we get summation delta mx squared. So we know the mass, so we have mr d theta dr, and the distance from the y-axis is nothing but r cos theta. So we get here r cos theta whole thing squared. So you try to simplify, so we get mr cube cos square theta d theta dr. So m you take out is a constant mr cube. We try to put the value of cos square theta. So we put the value here, cos square theta, we get 1 plus cos 2 theta by 2. 2 is a constant, we come out here. So if we integrate 1 with respect to theta, we get theta. Cos 2 theta, if we integrate, we get sin 2 theta by 2. So we'll try to put the limits, upper limit and lower limit. So we get here 2 pi. So this 2 cancel, we get here pi. And we try to integrate r. So we get here r4 by 4 and put the limits. So we get here ma square by 4. So in the similar manner, we try to find the moment of inertia about the z-axis, that is summation delta m x square plus y square. So summation delta m x square plus summation delta m y square. The summation delta m x square is nothing but it is b. Summation delta m x square is nothing but it is b, and summation delta m y square is nothing but a. So I've written here a plus b means a is for. I've written here a plus b means a is for this and b is for this. So we get here a plus b. So we have here ma squared by 4 plus ma squared by 4. So we get here nothing but ma squared by 2. So the moment of inertia about the z-axis is nothing but ma squared by 2. So same way here, if we put here in place of z, if we substitute here 0, then we get the moment of product of inertia to be 0. And in the same way for e also, if we put here 0, we get the product of inertia to be 0. So we try to find what is f. Here we have xy. So we try to put the value of m. So we get here mr d theta dr, and the distance from x-axis, distance of the point from the x-axis is r sin theta, and distance of the point from the y-axis is r cos theta. So we get here r cube 2 sin theta cos theta, means here I'm multiplying with 2 and dividing with 2. So we get here 2 sin theta cos theta, and that is nothing but sin 2 theta. So we integrate this sin 2 theta. If we integrate, we get minus cos 2 theta by 2 pi, 0 to 2 pi. So if you put this limit, so here we get minus cos 4 pi plus cos 0. Cos 4 pi is nothing but 1. So we get minus 1, cos 0 is 1, so we get here 1. So minus 1 plus 1, we get 0. So 0 into this will be get nothing but 0. So we get the moment of we get the product of inertia to be nothing but 0. So here the product of inertia f is 0. Thank you.